Now second experiment we are going to start. Second experiment of digital signal processing is implementation of DFT of given sequence. Okay, so here I have given a statement like this. Determine the Fourier transform of the following sequence. Use the fast Fourier transform algorithm, right? Okay, and equations input sequence is given. X of n is equal to, now you can choose any one sequence, right? मैंने यहाँ पर आपको एग्जाम्पल पॉइंट ऑफ व्यू दिया है 4 6 2 1 7 4 8. Okay, so this is a sequence. Okay, in case I will take a 1 2 3 4 also. So now I am showing you the code. Okay, now for this point of view I return this code three ways. Okay, so all these three ways I am showing you one by one, right? So first program is like this. Now here I first tell you about the all statements of the program, and then we will go for executions, right? This program is very similar to as your experiment number 1. Okay, only difference is here that the way of writing style, program writing style is changed. Okay, the outputs are very similar. Okay, because DFT and FFT, okay, both are giving you the same output over the discrete time sequences, so that's why their output narrations will be the same one, right? Only the technology for writing that program statements is different. See, one by one I am showing you. So here I define value of n is equal to 0 colon 6. Okay, so 0 to 6 means it will help me to show define 7 values. So here I am giving 7 values for x. X is equal to 4 6 2 1 7 4 8. Okay, total 7 values are given. So that's why x of 0 is 4, x of 1 is 6, x of 2 is 2, x of 3 is 1, and so on, right? Get everyone? Now for that x I means this is the x of n, so I am going to find out its fast Fourier transform. So I write a is equal to FFT of x. Okay, it is a ready-made function available in MATLAB. So within one line you can able to find out the fast Fourier transform of a given sequence. So FFT of x means here this sequence is passed to this function and it will find us the discrete fast Fourier transform, right? A carries that fast Fourier transform sequence, right? So that sequence magnitude I find with the help of ABS function, ABS in bracket A. So this function permits me to find the magnitude of that A. Similarly, I will find out the phase of that signal. So that's why again the angle name function that I already told you in earlier experiment. Okay, means already we use this ABS as well as angle x function. So again I am repeating here. Okay, so that's why we find the magnitude as well as phase plot. Okay, so for plotting this magnitude and phase plot, here I use figure. So subplot 2 1 1. Okay, 2 means total 2 rows, 1 means there is a 1 column and at first place, right? So this subplot is permitting me to divide a graph in two parts. First part will be given for magnitude and second part is given for phase plot, right? So here I first draw plot a magnitude, so that's why I highlighted some statements, right? So these statements are telling you here magnitude plot will be displayed. Okay, so that's why plot in bracket magnitude mag. Grid on is a function, it is used for turning on the grid of graph. Okay, as well as title magnitude response, right? Same I am repeating same code I am repeating for the phase. Only instead of passing magnitude here, a phase variable is passed to the plot, right? Now I save it and execute it. So for execution, press a green arrowhead button. Okay, you can see now arrow, mouse arrow, and if you press, you will get a execution. You will get a graph. Okay, so in this graph, two graphs are shown: magnitude response as well as phase response. Okay, so this is a fast Fourier transform of a given x of n sequence. Okay, getting everyone? Any doubt? Okay, if you have any doubt, you can ask, no problem. Now I am turning toward the second point of this experiment. Okay, means the same experiment I written by three styles. So this was the first style. Now I am showing you the second one style here. With this style here, without using inbuilt function, we are going to find out the fast Fourier transform of endpoint signal. Now here two functions I given, clear all, close all, and CLC. Okay, CLC means it clear the screen. Clear all variables are get cleared, and close all means all the variables are, means your window is get closed. Okay, so your command window as well as your variable window, okay, history window will get closed, right? Now here I am defining a x of n input sequence, so that's why x is equal to input, enter the sequence x of n, right? So it demands you the input sequence. Similarly the second one, n is equal to input. Okay, it demands you the how many n point sequence, how much n point sequence you are going to enter. Okay, that is pass. Okay, so that will be passed by you. But here again a verifications means how many actual variable are entered in x of n sequence. So for that point of view here, L is given. Okay, so I use here L. Okay, that L will help you to find out the actual variable entered by you. So that's why L is equal to length of x of n. So in case there are 4, then the value of L will be 4, right? So here this value will be calculated by the length name variable. Then x underscore n means whatever the x of n will be sequence. Okay, that x of n sequence will be written in a proper fashion. This proper fashion will be obtained by using insertions or additions of zeros. Okay, or additions of elements. Okay, means अगर आपको यहाँ पर n पॉइंट सीक्वेंस के अगर आपको लेंथ अगर चाहिए है, मुझे अगर 4 पॉइंट सीक्वेंस है, 8 पॉइंट सीक्वेंस है या 16 पॉइंट सीक्वेंस है, तो मुझे 4, 8 या 16 जो सीक्वेंस है वो प्रॉपर मिलाने के लिए मुझे यहाँ पर इस तरह का मैं यहाँ टेक्निक एडॉप्ट कर रहा हूँ. यानी मुझे अगर किसी ने 3 वेरिएबल दिए तो क्या होगा, तो I will not able to find out that particular sequence FFT. So for that I am giving now for that point of view here I am resizing at x of n. So that's why here x of n is equal to x. X means our all variable. Okay, comma zeros. Okay, means here we are inserting zeros. Okay, so that's why zeros are inserted by finding the subtraction, okay, between this n and l. Okay, so n minus l will be defining here. If you entered n will be 4 and the actual length will be 3, so that's why how many number you left by entering into the input sequence, 1, means 4 minus 3 is 1. So that's why here 1 0 we need to insert. So for that point of view here x of n will get reshaped. Okay, I hope getting this point got all of you. Okay, if I Okay, should I continue now? Okay. Now the next one here, for statement is written for in for I is equal to 1 to n, right here. Okay, in C programming we write with the help of bracket, but here in terms of MATLAB it is written with the help of this style. Okay, for I is equal to 1 colon n means it helps us to define the I variable having a initial value 1 and the last value will be n, and you can able to define the step value also. Okay, so that's why by default here the step value is 1. Okay, by default step value is 1 means we write here I plus plus or r minus minus. So in the same fashion here also the style that you can adopt, but that style you can adopt in loop. So instead that here in case if you need a step 1 value, then that by default the for will consider it. Okay, so here the statement will be looks like this: for I is equal to 1 to n, or for j is equal to 1 to n, right? Now here we are calculating this formula will be based over your summation. What x of k is equal to summation of n is equal to 0 to n minus 1. Okay, x of n e raised to minus j 2 pi nk. Okay, so that's why this formula is written in that fashion. Okay, so that's why temp is equal to minus, okay, minus sign will be there because of minus j, okay, and minus j 2 pi, okay, I minus 1. I minus 1 means what will be the value of that n, okay, and j minus 1. Okay, so minus j 2 pi nk, n and k will be written as a I minus 1 and k is j minus 1, right? And value n is an denominator, right? Got the formula? I hope everyone is getting this. Now after this here we are going to take the discrete. Okay, we are going to find out the fast Fourier transform. So for that fast Fourier transform point of view here we use here a matrix. Okay, so that's why here a matrix is written in this style, in this variable dft underscore mat in bracket comma I comma j, right, is equal to, okay, now here exponent. Okay, so that's why exponent is taken instead of a summation, so that's why exponent is given here. Okay, so exp in bracket complex in bracket 0 comma temp is that calculated value will be passed, okay, and that you will get a summation. Okay, so it will be calculating entire things, okay, and then end. Okay, so whole this loop is helping me to find the fast Fourier transform. Once the fast Fourier transform is got, okay, we pass it to this x of k. So that's why x underscore k is equal to dft underscore mat into x of n. Okay, so that's why here this x of n is a transpose, right? So it is written as a x underscore n, and along with here one colon sorry, semicolon is there. Okay, so that's why, sorry, single quote is given. Okay, so that's why that single quote is in defining that we are going to transpose that value. Okay, so that's why that transpose value is get multiplied with the matrix. Okay, and then you will get the x of k sequence, right? This style is adopted here, right? Now we are going to display that endpoint dft. Okay, so that's why here display x underscore k. Okay, disp in bracket x underscore k is used. Then again we are going for the magnitude as well as phase plot. So for that point of view here magnitude will be calculated with the help of mag is equal to, mag is name of variable, is equal to abs is absolute of x of x underscore k, and similarly the phase plot point of view here we use here a angle function, angle in bracket underscore x underscore k, and it is now multiplied. Okay, such fashion is not adopted in earlier one program. Okay, into 180 divided by pi. Okay, this is the actual formula. Okay, that formula is used for finding the phase angle, right? So in your book also this formula we have utilized for finding this phase as well as magnitude plot, right? And then we are going for the plotting. So for plotting point of view, here the same things are get repeated. Subplot 211, again 211 is in for telling you here 2 rows 1 column and first place. Okay, then stem in bracket mag. Okay, it helps you to plot the magnitude. Okay, now here only stem in bracket mag is given, so that's why you will get a plot in uh, point fashion, right? Then x label, y label, as well as axis is given. Axis here defined, means the screen size is defined, graph size is defined. Okay, whatever the x1 x2 y1 y2 limit is given, okay, with the help of that axis. Okay, so that's why here 0 up to n plus 1 minus 2 to up to max in bracket max प्लस 2, यानी आपको यहाँ पर x1 y1 x2 y2 इस तरह आपको यहाँ एक्सिस को डिफाइन करके दिया है. आप इसके द्वारा हम अपना जो प्लॉट है वो प्लॉट देख पाओगे. ओके, फिर से रिपीट किया है वही कोड वैसा ही, सिर्फ यहाँ पर मैक की जगह आपको दिखाई देगा फेज. ओके, स्टेम इन ब्रैकेट फेज. ओके, तो इस तरह रहेगा. और एक्सिस में ब्रैकेट में आपको रहेगा 0 n प्लस 1 माइनस 180 और 180. ओके, इस तरह आपको ये फेज प्लॉट होगा. ओके, मैं अभी इसको एग्जीक्यूट करने जा रहा हूँ. सो सी once when I execute, okay, again it demands me the same value. Now I pass it here 1 space 2 space 3 space 4, right? And here it is a 4-point sequence that I have to find. So for getting FFT, I entered this x of n and n value. Okay, you will get the FFT. Okay, so for that point of view here, you will get that x of k value is 10 minus 2 plus j2, means here instead of j here I is present, minus 2 minus I means j. Okay, minus j. Okay, but its value multiplier is 0. Okay, so that's why only minus 2 is present here. Okay, and minus 2 minus j2, right? So this value is here, right? And you get the graph. Okay, the graph will be observable like this. Okay, here you will see the magnitude plot. Okay, on x-axis frequency index is given k, and on y-axis magnitude index is given. Okay, so here the values are plotted, whatever value that I shown in the command window, that are plotted, and in bottom side you can able to see a phase plot. Okay, in that phase plot you will find the phase angle will be given, right? Now this is about the second one experiment that I shown here. Again the third one style is here. Okay, this is a direct style. Okay, now in this style here the same previous pattern is adopted. Okay, now here you can see this third style is starting with the help of these three commands: clc, clear all, and close all. Then x input is given. Okay, x input is written here, then n value is demanded. Okay, then display the Fourier transform signal x of k is given. Okay, now the code is starting from this point. Okay, earlier 3 lines are telling about the value reading of x, reading of n. Okay, already you heard it, and as well as it third statement is helping you to display the text, that is Fourier transform signal x of k. Now whatever highlighted statement that I given, okay, that is x is equal to FFT in bracket x comma n. Okay, it is highlighted because here now we are going to find out the first Fourier transform of the x of n. So that's why x comma n is given. N is the total length of the FFT, and x is telling you here the entered sequence. Okay, and in one statement you will get the value of x of k. Right now we plot it. So for plotting point of view, here again I highlight some few statements. Okay, these statements are like this: subplot 1 to 1, right? It means there is a one row and two column. Now 1 to 1 I change some style. Okay, means you will get a variety of figures. Okay, so 1 to 1 is telling you here one row, two column. Okay, and first place. Then stem of x means x of n is shown. Its input is, okay, its string or title is given as a input signal. Then x label, that is n, y label, that is x of n, and a grid. Grid is on. Okay, it tells you here the grid means the horizontal and vertical lines are shown over a graph. Then the same statements are repeated here. Okay, subplot 1 to 2, one row, second column, second place. Stem of x means x of k is plotted. Then title, then x label and y label are repeating. Okay, now this is about the third one program. Okay, I hope you got everyone every statements. In case if you are not getting, please quote me in my WhatsApp. Right now I hope everyone is getting this, so I go for executions of this. Okay, so just I run again it demand me the x of n, so I write 1 2 3 and 4. Okay, once you pass it again it demand me the length of FFT, so I say 4. Okay, I will get here the output, that is 10 minus 2 plus j2 minus 2 minus 2 plus minus j2. Right, so earlier also in earlier program also we got the same values. Okay, these values are repeating. I already said you that these three programs are very similar, only the writing styles is changed. Okay, now here this graph. Okay, you can observe this graph here. Input sequence is given 1 2 3 and 4. This is the input signal, and here in the right hand side you will see the FFT of inputs x of n is given. Okay, so here I hope you will see these blue lines. Okay, so that value is shown over this. Okay, so these values are shown like this: plus 2, okay, at 2, and at 4 it is minus 2, and at 3 it is 0, and at 1 it is 0. Right, so all these values are narrated here. Okay, now this is about the second one experiments. Okay, I hope everyone has got a clear idea about the experiment. Hope you will do it. Now I am stopping this video. Thank you very much.